Hi guys, in today's video we're going to be looking at a very simple sound experiment, one with which I'm sure most pupils and most teachers are familiar with, and that's the cup telephones experiment. Now normally I'd be of the opinion that this comes into the sort of edutainment category of things that are kind of fun but not necessarily that informative. But today we're going to be looking at ways of making this a little bit more impactful in terms of the actual scientific principles behind it. So, the procedure of actually making one of the cup telephones is very simple. Take two cups, poke a wee hole in each end, and thread some sort of string through it, tying a knot in the end. Now at the base level, what this can teach kids is that sound travels using vibrations. And that's something that, just by speaking into the cup and hearing it out the end, that becomes fairly clear fairly quickly. However, in terms of making this more of a scientific investigation, it can be useful to introduce some variables into it. Now, you can do this lots of different ways, but what I often do is I set up a carousel around my class with each table presented with a different research question. The class will move around from station to station and everyone explore different research questions, trying to use appropriate scientific methodology and using a fair test. Now, first of all, in order to do any test fairly, and just when setting up the cup telephones in the first instance, I want to be asking some prompting questions to my kids. So, obviously, if we're wanting to, let's say our question was to compare different materials. Does the sound travel, is the sound clearer through a thicker string or a thinner string? In order to make that a fair test, the sound, the only thing we should be varying is the thickness of the string. So I have here a thick cotton string, a slightly thinner woolen string, and then a very thin thread. I would also, in an ideal world, have procured some wire as well, because wire actually works quite well. It's quite an interesting effect that you get through it, but I wasn't able to find any in this instance. However, to make this a fair test, the only thing that can be varied is the thickness of the string. So, I'd be asking the kids, well, if I was comparing these particular strings right now, would this be fair? We can see that this thread is pretty long, there. The cotton one, significantly shorter, and this one's a little bit longer again, but not quite as long as the thread. Is it a fair test if they're all having to travel different distances? Well, not really, no, because then we can't tell whether the difference in sound is due to the distance it's travelling or due to the thickness of the string. So for it to be a fair test, I'd be encouraging them to think about making all the strings a standard length. And, probably a metre is good enough. So everything should be a metre. And the kids get that concept quite readily, that for it to be fair, always has to be the same length. So that's one way that we can increase the scientific impact of that. In terms of other research questions you might pose, and I would set up several of these. So one could be different types of string, maybe different density, so obviously wire is much denser. Other questions are, does it work going around a corner? Can you still hear each other if the string is threaded around the corner? They can just use the corner of the desk for that, but that would be for them to figure out a way of doing that fairly. Does it work if there is something on the string? If you pinch the string or place a peg on the string, does the sound propagate as effectively? Does it work if the string is slacker or tighter? There's any number of research questions you could come up with for this. And if you place a different one at each table and give them a chance to investigate each one in turn, while yourself going around and asking prompting questions to encourage the quality of their thinking, then it makes it a far more effective lesson. They actually gain some insight, not only into the way sound works, but into the way the scientific method works. And I find that a far more effective way of delivering that lesson. Cheers.